Hello, my name is Hugo and I'm part of the PyCore team. Today I'm gonna show you how to deploy your Py application on our infrastructure. To give you some context, when you go on the PyDeveloper portal and register your application, at some point we ask you whether you want to host your application by yourself or if you want us to host your application for you. If you decide to choose the second option and if your application meets all the requirements, then we will give you access to a GitLab group in which you will be able to push your code and from here deploy your application. This deployment process requires an initial setup that I will show you in this video. Everything starts here in GitLab, so we'll give you a GitLab URL so that you can access this subgroup as a maintainer. So the first thing to do is to create a new project here, which is like a Git repository, and the name, create a project, and then the first basic steps to initialize a Git repository. So I will not dive into the Git details in this video. And then we refresh the page and we have our code in the project here. So this is a basic application that is not production ready. We basically have a front end here and a back end, let's say, and we have a Docker file, which is very important because we want our application to be containerized. So your application must be containerized to be deployed. So now what we want is to organize a little bit this repository. So we'll go here, repository, branches, and we will create two new branches. One called development, on which we will work mostly, and another one called staging, on which we will push the code to deploy the application. Now we have these two new branches and we'll just customize a little bit the behavior. So we go to settings here, then repository, and we'll just change the default branch to make it development because it's the main branch on which we will work on, and then we will protect these two branches. So we go here, we choose development, then this, for example, and this means that anyone can merge the code on this branch, but no one can push, so that we force everyone to go to a review process, kind of protect it, and then we do the same thing for the staging branch. So the difference here is that we only want the maintainers to be able to deploy, to push the code here, to merge the code, sorry, so that only the maintainers can decide when the code is deployed. Because as we will see later in the video, when you push the code, you merge or push the code on the staging branch, then you deploy the code. That's it. And then we can even unprotect the master branch as we do not need it anymore. Here, repository branches, and we can remove the master branch. Okay, so now we can start the deployment process. And as we remove the master branch, locally we will also clean this up. So currently we're on the master branch, and then what we want to do is to go on the development branch. And then this, and we can delete the master branch. So that now we can work on the development branch. First, we can create a new branch starting from the development branch. So we can call it CI/CD for continuous integration and continuous delivery or deployment. And we can create a new file called .gitlab CI/YAML. This file will describe our deployment process, and this is what it looks like. So we have a first block here called stages that define basically the big steps of our deployment process. And then we have three jobs block here, and each job is run during a stage. So one stage can have one or several jobs, and in this case we have one job per stage. The first job, build app image, is run during the build stage, here. Then this job is run only if the commit branch, so the branch on which we merge or purge the code, is the staging branch. Then we define a variable, image name, that we'll use later in the process, in the job. Here, image and services is used to define the context in which we run the job. So what this means that in this job we'll run some commands, and these commands will be run in the context defined here. So basically we'll be in a Docker container. And what we want to do is to build our app image, so defined with this Docker file, and then we want to push this image on the GitLab container registry. So the GitLab container registry, for which we log in here, is here. Package and registry, container registry. So what this means that when we run this job, we will build a Docker image based on this Docker file here, and then we'll push this image in this container registry. The next step is deploy Kubernetes component. In this step, we will deploy our application in a Kubernetes cluster. Kubernetes is a tool to deploy and scale containerized applications. So I will try not to dive into Kubernetes details in this video, but I will show you what it looks like. Before to continue, I will just save this file and then commit it. GitLab CI file, and then we can start to set up our Kubernetes components. So we'll create a new folder called Kubernetes, and inside another one called config, and then we can create two new files, one for our application and another one for the Mongo database that we'll use for our application. Then in these files we will put the configuration of the Kubernetes components needed for that. So I'll just copy paste again existing one that I made for this application, and then we'll describe them. So this is for the application, and there is another one for the database that looks like pretty much the same. Before to continue, I will just commit them Kubernetes components configurations, and we can start to explain a little bit what this is. The first file, app.yml, contains 3 Kubernetes components separated by 3 dashes like that. So we have one config map component, one deployment component, and one service component. The main one is the deployment component, in which we define our application container. So for this container, we will use the image we built during our first GitLab CI step here. And then we define the port used by our application, which is 3000 in our case. And then we define a bunch of environment variables used by the application. So the application only needs 3 variables: a database name, a database user, and a database password. And we define them here, 1, 2, and 3 for the password. These variables come from another component called config map, in which we define the variable. So here we only define the database name, because the 2 others are secret variables, password and database user, and we will define them later in the script. Then the third component is the service component, and this is basically the endpoint of our application. So we define a port 3000 that will match our container port, and this will expose our application to other Kubernetes components. Then in the MongoDB YAML file, we do pretty much the same, but for the database. So here we only have 2 components, a stateful set component and a service component. In this stateful set component, we define the container used for our Mongo database. Here we will use the official Mongo database image, and in the same way we will define the container port. This one is the default for MongoDB, and then we define 2 environment variables used by our database. Again, as these variables are secrets, we will define them later in a script. And then we define a service to expose our Mongo database to other Kubernetes components in the cluster. So the main difference between this service and this service is that this service will expose our application to the world, so outside our cluster, so there is a load balancer type, while this service will expose our database container only inside the Kubernetes cluster, so no one will be able to access this database from outside our Kubernetes cluster. Now we can go back to our GitLab CI file and see what this deploy Kubernetes components does. So this job is run during the deploy stage, and only if the commit branch is the staging branch. Then we define the context of this job, which is a kubectl Docker image, kubectl being a specific Kubernetes tool to run command line. Then we define an environment. So this environment must be configured on GitLab under deployment environment. So here, and then we do new environment, and we create one, we call it staging, we save it, and now we have our environment. So for this video, we will only have one environment, staging, but for real application, we will have several environments. For example, staging and another environment, production, so that we can deploy code on the staging cluster to test things, and we can deploy code on a production cluster for the real application. So we can go back to the code and see what we do in this job. So we call a script called deploy Kubernetes component that will do a bunch of things. So here, instead of directly applying comments, we do a script to reduce the number of lines of this file and have something more organized. So here we create a new folder, script, and we create a new script called deploy Kubernetes component. In this script, we'll put this. We can save it and then commit it. Deploy script, and we push later, and then we can see what this script does. This file does a lot of things, so I'll try to explain every single part correctly. So the first 3 blocks here create a secrets component, secret Kubernetes component. So secrets component work a little bit like config map. They define variables that will be used by our application or other Kubernetes component, but we prefer to define them directly in a script with a kubectl command. The first one creates secrets for the Kubernetes cluster to be able to talk with the GitLab container registry. The variables defined in the secret are used by the Kubernetes cluster to register against the GitLab registry. So these 4 variables are defined by GitLab, and we do not need to create them somewhere. The only thing we need to do here to make this work is to go to the GitLab interface, to settings, repository, and then deploy token, and here we need to create a deploy token. So this token must have this name, GitLab-deploy-token, and we add it the read registry scope. Then you can create a deploy token. It will give you a password that you do not need to save, and you can just quit the page. I created my deploy token, so now we can go back to the code, to the script, and see what are the next comments. The 2 next comments are the same, kubectl create secret, but this time we want to create secrets for our application and for our Mongo database. So the first one will create a user and a password, a root user and a root password for the Mongo database. This will be used by Mongo to initialize the container and the database. And here we create a Mongo user and a Mongo password for the application, so that we have 2 different users. We have one root user and one user used only for the application. So how this works? So here we define a variable, for example this one, MongoDB root user, and we say that this value is this other variable. So this variable is not created by GitLab. This is passed by GitLab to the script, but we have to create it on GitLab. So this is created on the GitLab interface. Here go back there, and then we go to CI/CD here, and then variables, and then we can add a variable. So we create a variable, this one for example, and we say root, let's say, for the username, and we say that this variable is for the staging scope. This means that this variable will only be accessible from jobs running on the staging environment. Let's say root user, and here what we can do is that we can mask the variable so that this variable does not appear in the job logs. So we do that, and then we have our variable. So I will do the same for all the other variable, and I will be back. I created the 4 secret variables we need, and we can go back to the script. So now these 4 variables are defined and are passed to these 4 secret variables. So let's take this one, for example. So here we create a secret called Mongo app secret, and we define these 2 variables. And if we take this one, it takes these values that we just defined in the GitLab interface. And now to use this value in our Kubernetes component, we do it this way. So we go to the component in which we want to use a variable, and we create a new entry in the environment section. Here we put the name of the variable. This name is the name that we will use in our application. So in this case, Mongo DB app password with caps is used in our code. Then we say from where we have to take this value. So this value comes from a secret component with the name Mongo DB app secret. This name is the name of our secret component created here, and then we say that the key of this variable is this, and this key is what we have here. So basically when we want to use a variable in our application, let's say this one, so this is a variable we want to use in the application, we take this, we create a new entry here in the environment section with the name we used in the application, and then we just specify the secret in which we define the variable and the key of this variable, and then we just add the value here, and that is. The next command of the script is this set command, and what it does is that it takes this variable and it replaces this string contained in this file by the value of this variable. The same for this variable that replaces this string in this file. So for the first one, Mongo app database name, this value comes from, again, the GitLab UI interface, so we can create it here. App db, let's see, environment scope staging, again, we do not need to mask the variable as this is not a secret variable, so we add the variable, and then what it will do is that it will take the value here, this value, it will replace this string by this value, so this string is the one we define here, and this key is used here, and this variable is this one, and we use it directly in the code here. So if we recap, the value of the value of this variable used in the code is defined here, and it comes from the app config map, which is this config map, and it uses the key, the variable named MongoDB app database name defined here, and the value of this variable comes from this string that is replaced in the script by this value, which is defined here. Now the second variable comes from, so image tag comes from the GitLab CI file directly, and it is defined here, and basically this is a path to our Docker image stored in the GitLab registry. So once this command is run, our configuration file for Kubernetes are ready to go. And the two last commands of this script are kubectl apply commands. So when they are run, Kubernetes will start to create a Kubernetes component based on what we defined in these two configuration files. So when this is run, our application will start to be deployed for real. And for this script to be run, we need to run this job here. And to run this job, we need to push or merge our code on the staging branch. So this is what we'll do now. And just before, I will add this script used in the last job, and I will describe it later. I'll just add this script here so that we have it. And now we can push our code. And now we can push the code on our CI/CD branch. Then we can go on the GitLab interface here, and we can go to merge request and then new merge request here. We can select the CI/CD branch and we can merge it into the development branch. Compare branches and continue. CI/CD. Create a merge request, and here you can do some PR review if you want before to merge the code here. So we merge the code and we delete the source branch, which is CI/CD, to keep our branches clean. Merge the code, and then once it is done, we have our code here. Then what we want to do is to merge the code on the staging branch. So we come back to merge requests, new merge request, and we want to merge the development branch into the staging branch. We do that, and we'll say just staging, let's say, probably a bad name, but anyway, and then we create the merge request. So when we will press this merge button, GitLab will see that we have a GitLab CI file, and he will start to execute that file. And as we are on the staging branch, then GitLab will execute this job, and we will build our Docker image, and we will deploy our Kubernetes component in the Kubernetes cluster. So we can go and press the merge button, and then when it is merged, we can go to CI/CD pipeline and follow the deployment process here. So this pipeline should take about 2 or 3 minutes to run, to finish, but Kubernetes deployment behind will take a little bit more time. So I will come back when everything is ready. The pipeline completed, and as you can see, we have these 2 green check marks. It took about 2 minutes for the pipeline to finish, and then I waited a little bit more, like 10-15 minutes before to come back for the Kubernetes components to be fully deployed. What you can do if you have an issue here, you can click on this bubble and then click on the job name, and you will see the job logs. So here everything went fine, and the other job here, deploy Kubernetes component, went fine too. So you can see that all our component got created successfully. Now, to know whether your application is deployed, what you can do is that you can go to the monitor section and then logs, and you will be able to see the logs of your application. So here you have the logs of your application, and here you have the log of your database. So when your application is ready, that means that your deployment is completed. At that point, the next step for you will be to ask the PyCore team to create a domain name for you. So what we will do is that we will bind your application endpoint service to a real domain name so that you can access your application on Google directly through a domain name. The process might change in the future, but for now you can ask us on Discord for this domain name. So I created a domain name for this app, video-demo.devstaging.py.app, and we can see that it works fine. There is something missing here, which is an input form, and this is because we did not finish to set up the Mongo database. So if we come back to the code here, our application needs to connect to a database, a Mongo database, and it needs to connect to this database, the app database name, with the app user and the app password. The issue here is that we did not created the app user yet, and this is why we created earlier this create MongoDB script. When this script is run, it creates a Mongo user using the secret we defined earlier here, Mongo app user and Mongo app password. And this script is run when we trigger this GitLab CI job. The only difference between this job and the previous one, except the different script, is that this job is a manual job, which means that we need to trigger it manually from the GitLab interface. So we can go to the GitLab interface here, and then in CI/CD pipelines, and here you see we have this manual job, create Mongo database user, and we can just push the play button to run it. So again, it will take some time to create the user, and I will come back when it is done. The job finished and everything went fine. So now, to make sure everything is good, you can go to logs, and then you should see a broken client pod. You can click on this and see whether the user has been created successfully. I will not click on it in this video because it shows the Mongo logs and the database password. So now we can go to the app and refresh the page, and we can see that we got this from the database, so the connection is successful. Now we can edit the name, bug demo, and we can update the name, and if we refresh the page, we still have the new name. So the database connection works. Now let's say we want to add a new feature to the application. So we can go back here and create a new branch. So first, let's see where we are. So we go back to the development branch, and we can remove the CI/CD branch as we do not need it anymore, like this. And then we can make sure we have the latest state locally, and then we can create a new branch that we can call new feature. And now we are on our new branch, and we can go back to the code. We'll do a very simple change, so let's close everything, and on the front end, instead of displaying video demo for the name, we'll do video demo new feature. Save the file and then add it and commit it. Add new feature. And now I can push the code on my new feature branch. I can go on the GitLab interface here, go to merge request, create a new merge request, and we can select the new feature branch, and we want to merge it into the development branch. Okay, convert branches and continue, create a merge request, and then after the code review we can merge the feature. We can reload here, merge, and now our code is merged. So we have the new feature on the development branch. Now we can merge it into the staging branch, so that let's check status, new feature, create merge request, so we can merge it into the staging branch so that it is deployed. So when I press this button here, I can go to pipelines, refresh the page again, and we have our new request that is running, and now we can wait a few minutes for it to complete. It should be, this time it should be much faster than the first time, so in 2 minutes we should be good and see our new feature on the application. There is no need to wait again for all the Kubernetes components to be deployed completely. So the pipeline finished, and it took almost the same time than the previous one, but this time we do not need to wait 10 extra minutes for Kubernetes to create all the components. Everything is already created, and we will just and Kubernetes will just refresh one component to add the new feature. Concerning this job, we don't need to run it again because we already have our Mongo user. So we can go now. If we refresh the page, we have our new feature. The last thing I wanted to say is that when we invite you on GitLab and give you a subgroup for your application, in this case video demo, we'll also give you access to a documentation group inside which you will find the Cube demo project, which is exactly the same than the one I used in this video. So if you want to use the code showed in this video, you can go there and copy the code. You will also find a wiki project that explains, but with much more details, what I described in this video. This is the end of the video. I hope I've been clear enough. If you have any questions, you can post them in the comment section or on Discord. Bye!